Alright, I'm going to walk through the numerical analysis 1 assignment here in a desktop session to give everyone an idea of what it is we need to do to fulfill this assignment. Hopefully, my computer's been acting up. Hopefully this all holds together. You can see I have the Excel sheet open from the template I downloaded off Angel, and I'm going to remind everyone right off the bat to save this as the file that you need to submit. So just following the format that we need or is specified in the assignment sheet. Start with the course Math 141G, Spring 2014, and this is going to be me, section X, and we're going to save this locally in this file name. Make sure it's an Excel workbook 2010. Alright, got this saved. Save often, save frequently. Here's the situation. Here's the integral that we want to go through and integrate. We need to, for part B in the assignment, I asked you to solve this analytically paper pencil. You need to go ahead and do that. Find some way to get an exact value for this, and I'll give you a general answer. I'm not going to carry it out to the number of decimal places that you need to give me, but I'll start with a pretty close answer for the exact value of this integral. The second thing that we need to do, this is going to be part C in the assignment. Here we have n equals 10. That's the first part, and we need to go over here to cell B9, and we need to come up with an arithmetic expression for delta x that reads in this cell, and this cell, and calculates a delta x. So here you can see that I've entered a value into delta x based on these. If I change my bounds, you can see delta x changes. If I change the number of n that I need, you can see that delta x is updated. Now, the very first thing we need to sort of get the approximate integration going here is we need to create a sequence of independent variables for our x. And the independent variables are going to range from our bounds, -2 to 1, and they're going to increment by delta x. So I'm going to start with the very first value. It's always going to start with a. So I'm going to let this be f7. And then the second value is going to increment by delta x, and it's going to lead off of this value right here, a12, which is -2. So I'll start with that, and this is going to increment by delta x, so I'm going to select B9. And what I'm going to do with B9 is I'm going to make it an absolute reference, so that when I drag the cell or propagate the equation, that it does not increment this cell reference. So I can press the F4 key, and you see it will insert dollar signs in front of the B in front of the 9. If I keep toggling the F4 key, it will cycle through the all of the dollar sign options, or the absolute cell reference options I have. To be just to show you the flexibility of absolute cell references, I'm going to just leave the dollar sign in front of the 9, and that way when I drag the cell, it's only going to freeze the row. It's not going to freeze the column, which I don't care about at this point. So you watch, I'll drag this down. There we go. And here I have -2 to 1. I need to go and get my f of x values now. What I'm going to do is I'm going to build another equation. Always start with an equal sign when we need an arithmetic expression. Those of you who took 140G, this is a throwback. I'm going to raise e to a power, but I'm going to use the exp function. I'm going to raise my independent variable, which in the function is stated as x, but really for the purposes of this analysis is this number -2 over here. I'm going to just leave this reference as a12, and then I'm going to multiply that times the square root of 1 plus e to the x. Use my exp function again. You see how this has hidden the cell, which is an annoying, side effect of using these cells. I'm just going to type in A12 because I know it's the cell there. Sometimes it's easier to go up here to the formula bar and work on expressions. It's an easier editor. I should be able to check all my parentheses, make sure everything's closed, make sure I have my multiplication sign in, and run that. And I get a function value. This is -2 evaluated at cap f of x. I'm going to hover over the hotspot on this cell. You see that there's a hotspot right here. And what this is going to do is I can drag it down like that, or I can double click it and it will fill it in for me. It looks for the adjacent column. It knows where this column ends, and it will fill this column into the bottom, which is a very handy feature. My next column, my average x. Okay, I need to do this to evaluate the midpoint approximate integration. So I'm going to, what this is doing is I need to average pairs of my x. So I'm going to go down one because I'm going to start averaging these two pairs. I'm only going to end up with 10 of them. So what I'm going to say is 0.5 times this plus this. That is the average of these two x values. See, I get it blanked out. That doesn't mean anything wrong. I just have to go and make the column wide enough so I can go up here between C and D. I can hover over the cell boundary, double click, and it will automatically size it. So here we are, 6 decimal places, the average of -2 and 1.7. Yes, that makes numeric sense. An alternative to writing out this entire function is to use the built-in average function, where you can type equals average, and then you can simply enter your two values, comma, and you could also enter it that way. If you're ever at a loss to know what functions are, or if you need to be reminded of how a function works, you can always prompt, just type the equal sign. You see this window over here turns into a function. You can always bring up all of the catalog functions by going down to more functions. It brings up a dialog box of every single thing that's packed into Excel. And so they're also categorized. Here's the math and trig. You can see that the square root that I used earlier is in here, etc., etc. This is a much easier way to get to the catalog of functions than going through the Microsoft Help menu. Carrying on, we're going to just propagate this down. And here's the average for all of those values. Now, this is the midpoint of each of the subintervals. I want to now evaluate each of these midpoints at the function. So I'm going to do a little cheater. I'm going to go back to my function. I'm going to go up here to the formula bar, and I'm going to copy the whole thing. Highlight it, Control C, come down here to midpoint. I activate this cell. I go up to the formula bar, Control V, cut and paste it in. Now I'm going to make one amendment. This is going to calculate the function. I need to change this cell value to my x bar, or my average x, which is going to be C13. You see it highlights the cell that I'm calculating. I need to change this to C13 as well. So this is now going to evaluate cap f of x, this function. It's going to evaluate it x bar right here. So this is how high my subinterval is. Remember, the area of a rectangle is length times width. So I can do this all in one formula. I need to multiply the length here by the width of the rectangle. And I need to do that by multiplying it by my del x. That's the width of my subinterval. So I'm going to simply say this multiplied by my length. This is length times width. As I'm just calculating the area of my subinterval. Click F4. Puts an absolute cell reference. Again, I only have to lock the row. It's not a big deal either way. If you have all dollar signs, it will not affect the performance of that. Let's re-drag that. And now I get midpoint values for all of this. So this is my length times width. This is the area of all of my subintervals. I can go up to here, my midpoint, and I'm going to add them all together. And I'm going to use the built-in sum function, which is a very good way to take a whole column of values and add them together rather than typing it all out. And you can see I get a value that's reasonably close to my true area. On to the trapezoid method. Okay, so we finished the midpoint. We're going to move on to trapezoidal rule. I'm going to do one thing with my trapezoidal rule to start things off. You know that inside the trapezoid sum, there are those coefficients that all of the middle values get multiplied by 2. So I'm going to add some coefficients in. Rather than worry about doing this formulaically, for small numbers of n, this is probably the easiest way to go about this. You could do this programmatically if you'd like. There's actually a couple tricks you could use to work this into a formula. Now what I'm going to do is I'm going to say this is equal to my coefficient times my function. See, this is my f of x0 times 1. The next one will be f of x1 times this 2, etc. So I'm going to enter that, and I'm going to just drag this down. 6 decimal places seems to be consistent with everything else here. I'm going to make this 6 just to keep things squared away. So here's my trapezoid rule. What I need to do now is I need to go up here to my sum. Now the trapezoid rule, the sum part is multiplied by delta x divided by 2. So I'm going to do my delta x divided by 2 here. I don't need to worry about any absolute cell references or anything because I'm not dragging this. And then I'm going to multiply this times my sum, which is this. That's a very handy way to construct this expression. And I got 4.02. Okay, you can see I finished up Simpson's rule. I added my coefficients in. They alternate. Make sure you start with 4 and end with 4 on the middle terms. And applied that to my function. I got all these values, and here's my sum for Simpson's rule. You can see all these values are very reasonably close to one another. We're going to move on to the error analysis, and I'll show you guys how to start plugging away at this error analysis. So now that we know that this is 11 and this is 23, we can go ahead and we can calculate our theoretical maximum error. And we're going to use the equations on the assignment sheet for midpoint error, trapezoidal rule error, and Simpson's error. So what I'm going to do is I'm going to say this is equal to, this is going to be EM, E sub M, is equal to B minus A. I need to group those together. If you have to revise your formula, it's best to go up here to the formula bar up top. And I'm going to divide that by 24. I'm going to multiply this by delta x squared. I'm going to lock that one down because I'd like to be able to drag this in here in a second. Square that, and I need to multiply by my k. And my k for midpoint is the second derivative, so I'm just going to select that cell and I'm going to lock it down so I can drag it. That's possibly optional. So here is my value for the estimated error for midpoint rule. And I get 0.12375. The actual error for midpoint is going to be the difference between f of x, technically it'd be the absolute value of this minus that. The difference between the approximate integral, or the approximate area, and the actual area. No percentages or anything, it's just a true difference. I absolute valued it just to keep the sign out of the discussion. And yes, this is much less than that. That's typical. Remember, this is a maximum error. Okay. Okay, I filled in the rest of the actual error by comparing the true value with my approximation. And I completed the maximum error, theoretical maximum error calculations for each of these three methods. The only discrepancy is Simpson's method. The maximum error here is showing as 0.00311. And here, this is bigger because I didn't enter enough decimal places here. Once you fill this value out to its complete accuracy to 6 decimal places, this should tidy up. And this is how you navigate the exercise for this. The part J for the assignment is to take this. You're going to go down here to the tab. You're going to copy, move or copy. And what you'll do is you'll select Create a Copy Radio button. And what it will do is it will create a second sheet for approximate integration. You can sort of slide that around like that. And you're going to carry out the same process for a different integral, but it's going to be this integral is what you're going to evaluate. So, and you're going to be having a different n. You're going to change this to 30. You'll have to drag this out further and just rebuild the same thing. It should be pretty quick process to adapt this to this. And that's the assignment.